All right, the first thing you want to write down is to evaluate an expression. Let's turn the talking off. You should be writing. To evaluate an expression. Y'all over there keep on. I'm going to give y'all a point, and I'm not going to tell you when. To evaluate an expression, substitute the given value for the variable. Then simplify using order of operations. So the first one I want us to do is 48 divided by x. This is our expression, 48 divided by x. And x is going to be equal to a number of different things. So x is equal to, a number of different numbers, not things. 12, 6, 4, and 24. So we want to solve for what will this expression be equal to if x is equal to 12, 6, 4, and 24. So let's start with 12. We're going to just substitute 12 in for x. So 48 divided by 12 is, what's 48 divided by 12? 4. 48 divided by 6, 8. 48 divided by 4, 12. And 48 divided by 24, 2. So we've evaluated this expression for 4 different numbers. All we did was plug in the numbers and simplify. Let's do another one. This time I'm going to use the variable n. Our expression is 5n minus 4. N is going to be equal to 4, 6, 8, and 12. So I want you to plug the variable n into the expression and then solve. So for the first one, we have 5 times 4 minus 4. So using order of operations, what's 5? We got to multiply first. 5 times 4 is what? 20 minus 4, 16. And so when we plug in 4, our expression is equal to 16. Let's do the next one. 5 times 6 minus 4. 5 times 6, 30 minus 4, 26. So when we plug in 6, our answer is 26. Let's try 8. 5 times 8 minus 4. What's 5 times 8? 40. 40 minus 4, 36. And then 5 times 12 minus 4. 5 times 12, 60 minus 4, 56. So that was simple. All we're doing is plugging in what they're telling us it's equal to and solving. So let's do another one with an exponent. So I have t, and our expression here is 8t squared. And I want my t to be equal to 1, 3, 0, and 2. So I'm going to write the first one out. 8 times 1 squared. Please leave the door cracked. So we have 8 times, are we multiplying the 8 square? Are we squaring the 8 or are we squaring the 1? Only the 1, right? So 1 squared is what? 1, because 1 times 1 is 1. So 8 times 1 is 8. Now going on to the next one, we are going to be squaring what number here? 3. So 3 squared. So 3 squared is what? 3 times 3. So 8 times 3 times 3. What's 3 times 3? So we have 8 times 9. And what's 8 times 9? 72. Now we have the number 0. So 8 times 0 squared. And what is 0 squared? 0 times 0? 0. So we have 8 times 0. And what do we get? 0. Let's try 2. 8 times 2 squared. So what is 2 times 2? 4. So 8 times 4. 8 times 4 gives us 32. All right, this last one I want you to try. Well, this next one I want you to try on your own. So we have x and 32 divided by x. 2, 4, 8, and 16. So you go ahead and try this one. The expression is 32 divided by x. All right, I'm seeing some good work on your paper. So we have 32 divided by 2. That gives us what? 16. 32 divided by 4. That gives us what? 8. 32 divided by 8. 4. And 32 divided by 16. 2. So now I want you to try another one, but this time you're only going to plug in one number. So we have s squared minus 12. S is equal to 4. So s squared minus 12, where s is equal to 4. Does anyone want to show the class what they did? Bren, take your notebook up to the front, to the board thing. All right, just sit on top of my paper. All right, when you're ready.
What I did was I plugged in s squared minus 12, and that would equal 4 squared minus 12. And so 4 squared is 4 times 4 minus 12. 4 times 4 is 16, and then you subtract 12, which would give you 4.
Perfect. All right, did everybody get that answer? Yes. All right, good. So let me give you another example. All right, this one is a little, you have more than one place to plug in the variable, but you can do it. So we have x divided by 7 plus 2x, and x is equal to 14. So x divided by 7 plus 2x, and x is equal to 14. Make sure that when you're doing this problem, there are 2 places where you can plug in that x. 2 places where you can plug in 14. Use your substitution. So don't just put it in one spot and still have an expression. Plug it in both spots and get a number for your answer, not an expression. Can I have a volunteer to show the next one? Israel? Oh, maybe turn on my random number generator? Yes. Turn it on. All right, so we have 32. 1. It's you, Brianna. Come on up. So even if you did not finish, we are working together here. So come on up, Brianna. Come show the class what you did. Come on, you can do it. Bring your paper. You can bring the whole entire notebook. Come on. Y'all know how the number generator works. The number that's chosen, we're going to wait for you to get up here. Come on. Come on, you can do it. This is a judgment-free zone. We are all working together so we can understand this stuff. Come on. We're going to wait patiently for you. We're not changing it. The number generator has spoken. So it doesn't have to be correct. It doesn't have to be done. We just want to see what you did, and we will help you through it if you haven't finished. So bring that notebook. Come on, collage. Right now your time to explain. Come on. We can explain when you bring your paper up. Okay? All right. Just sit there. All right. Go ahead, Brianna.
Divided by 7.
All right. All your attention should be on Brianna.
2. 2 times 4.
This is not how the classroom was just a couple seconds ago. All your attention needs to be on Brianna. Go ahead.
I just did 14 divided by 7, and then 2 times 14, and then added it up.
Okay. Does everybody agree with her answer? Yes. All right, you did it perfectly. Why are you so scared to come up? You did it perfectly fine. All right, we have, let's do, see how much time we have left. All right, we just have a couple more minutes. I want us to talk about, I'll wait to have everybody's attention. I want us to talk about variables that are changeable and constants that are unchangeable. So looking at these few different options. So the number of days we have in March, is that an unchangeable or changeable? Is that a changeable variable or is that a constant? It can't change. It's a constant. So this is a constant. So if we were to be talking about in a problem the number of days in March, we would have to put the exact number of days in March. What about a price of a cell phone? It can change. It can change. So if they're telling us about a phone company selling this phone, Metro versus T-Mobile versus whatever, we can use that as a variable to represent the price of this phone. So we would use a variable. What about your height? That can change. People grow overnight. Not like a lot, but we grow. I'm done growing, but y'all not. What about the number of ounces in a pound? Constant. A variable? Is that going to change tomorrow? Okay, so the number of ounces in a pound is constant. They've already set that for us. Yes, Kalash.
So for the number of days in March, what if you were talking about February?
That's a different case. But if you ever get a problem like that, they'll most likely tell you it's a leap year or not. Yeah. Number of feet in a mile. Constant. Number of text messages sent per day. Number of students at school. Number of hours in a day. Constant. It's still the same number of hours.